Look at this question. It looks so beautiful. Tan inverse of this, and you have to prove. So if you see on the left hand side carefully, outside is tan inverse. If I can substitute something inside so that I could get in term of 10, this function can be simplified. Also here, one thing should be noted, the domain is given from -1 by root 2 to 1. What we can do here is, let's put say x is equal to cos 2 theta. How will this help? See, this become 1 plus cos 2 theta, which is 2 cos square theta, and this is 1 minus cos 2 theta, which is 2 sin square theta. So we had the formula for the cos 2 theta. Cos 2 theta was, we had 3-4 formula for this. So I'm writing just two which we are using here. One is 2 cos square theta minus 1. One is 1 minus 2 sin square theta. We simply rearrange them and we get the values here. Okay. So what do I get? The left hand side becomes tan inverse. Here you see under root 1 plus cos 2 theta minus under root 1 minus cos 2 theta and divided by under root 1 plus cos 2 theta and plus under root 1 minus 2 theta. Okay, so this thing will become tan inverse left hand side. So tan inverse, this is 2 cos square theta, simply applying formula, and the square root minus 2 sin square theta divided by square root of cos square theta minus 2 sin square theta. So far, so good. So here we have tan inverse. Square root 2 can be taken common, and then I get cos theta minus sin theta divided by square root 2 common cos theta. I think this quantity here, this was plus. Alright. So this square root 2 and square root 2 should be crossed out. Okay. And what I am left with is equal to tan inverse cos theta minus sin theta by cos theta plus sin theta. The inside bracket quantity can be further changed into dividing numerator and denominator by cos theta. See, this becomes cos theta by cos theta, which is 1. This becomes sin theta by cos theta minus tan theta. It was inverse, right? Okay, divided by 1 plus tan theta. The purpose here to get this a function of 10. Now, if I look carefully, this is a function of 10, which can be written as tan inverse of 1 minus tan theta can be written, 1 is 10 pi by 4, 10 pi by 4 minus tan theta divided by 1 plus tan theta can be written as 1 into tan theta. So I will write, in place of 1 I am writing 10 pi by 4 and into tan theta. Obviously this is a formula of tan A minus tan B, so which is tan inverse tan pi by 4 minus theta. So tan inverse of tan pi by 4 minus theta. Now as inverse and tan should cancel out, so I should get pi by 4 minus theta. And since in the beginning we will see what did we, when we put what was theta, when we substituted this in the beginning, okay, yes, x is equal to cos 2 theta. When we put, we should write it right here. When x was cos 2 theta, can be written as 2 theta is equal to cos inverse x, or theta is equal to half cos inverse x. I can also write theta is equal to half cos inverse x. Alright, so we will go and write the value there. Theta is equal to half cos inverse x. So this is equal to pi by 4 minus half cos inverse x. One thing we need to show that this value of theta, which is pi by 4 minus theta, should lie in the range of tan inverse x. The range of tan inverse x is minus pi by 2 to pi by 2. So we need to show that this value lie between minus pi by 2 to pi by 2. For that, see, our range was, I'll write here, because I was given minus 1 by root 2 was less than equal to x was less than equal to 1. Yes, and x I have taken cos 2 theta. So that means cos 2 theta is less than this. And where is cos 2 theta 1? Cos 2 theta 1 is in 0. So 0 is less than, and we know for the cos theta, the range is, for cos inverse x, the range is 0 to pi. So this is 0 is less than 2 theta and is less than equal to cos theta is minus 1 by root 2 for 3 pi by 4. You can see since this range of cos inverse is 0 to pi, so cos is negative in second quadrant somewhere here. That's why we write 3 pi by 4. Now you see theta was this. Okay, and this means, what about theta? When I divide this by 2, I get 0 is less than equal to theta is less than equal to this is 3 pi by 8. I divided this whole inequality by 2. Now since I am concerned with pi by 4 minus theta, so I will change all the sign. When we change the sign of the inequality, the inequality changes. So this thing will come first. Minus 3 pi by 8 is less than equal to minus theta is less than equal to 0, because negative 0 is 0 only. Did you understand this? If no, I can write here, I can show you a relation. See, suppose 2 is less than 4 is less than 6. Okay, but when you change the sign, what becomes? Minus 6 is less than minus 4 is less than minus 2. Is this true? Both the things are true, right? So when you change the sign, the inequality changes. So it comes like this. Now when 3 pi by 4, I am interested in pi by 4 minus theta. So I will add pi by 4 in every term. So I get pi by 4 minus 3 pi by 8 is less than equal to pi by 4 minus theta is less than equal to pi by 4 minus 0 or plus 0, whatever. This remains this only. So what we get from here? We have just proved that pi by 4 minus 3 pi by 8 will be, you will take the LCM 8, this become minus pi by 8 is less than equal to pi by 4 minus theta and is less than equal to pi by 4. Okay, so what did I get? Minus pi by 8 is like half of pi by 4, so negative. This simply means our angle pi by 4 minus theta is in this range. So that means pi by 4 minus theta also belongs to this thing. This angle belongs to the range of tan inverse x, that is minus pi by 2 to pi by 2, right? So when this is true, then only we can say tan inverse of tan theta is theta. That's what we showed here. Tan inverse of here, right? Tan inverse of tan theta is theta. So you can write this, but you need to show this thing also. All right. Hope you understood this and the concept of the inverse trigo.